All right. So from the last unit, you remember that we did the segment addition postulate, which basically said if you have a diagram that looks like this, if I know the lengths of these two parts, I can add them together to get the length of the whole segment, right? That's the segment addition postulate. Just like that, there is an angle addition postulate. It says if a point lies in the interior of an angle, then the sum of the measures of the two smaller adjacent angles, remember adjacent means right next to each other, is equal to the measure of the original angle. So, actually, I don't know that we talked about adjacent yet. So, adjacent means right next to. We'll talk more specifically about what it means for angles to be adjacent later. There's actually a definition for it. So, we're going to do this problem one step at a time. It says if h is in the interior of angle FGY, the measure of FGH is 28, and the measure of YGH is 43, find the measure of angle FGY. So we start with this first part. H is in the interior of FGY. So we would draw something like this. Now, we don't know how big angle FGY is. I usually draw it as an acute angle. You can draw it as an obtuse angle if you want to, but we have no idea what size it is. And then H is somewhere in the interior. Then it tells me the measure of angle FGH is 28. So in order to see angle FGH, we need to see both of its sides, both GH and GF. Remember, the sides of the angle are always rays, and they always start at the vertex and go away from it. So here we'll put this as 28. And then it tells me the measure of angle YGH is 43 degrees. So we're already on to the next page. I just wanted to show you this one step at a time. Now we're going to apply the angle addition postulate. To get the measure of this whole angle, all we need to do is add together the 28 and the 43. And I find that this whole angle has a measure of 71 degrees. All right, let's do this one together. It says R is in the interior of angle WTY. Which point is the vertex of that angle? T. W is on one side and Y is on the other. Yes.
So the middle number is always going to be the vertex.
The middle letter? Yes. Yes, yes. So what it does is it goes one side to the vertex to the other side, which if you were trying to draw this, W to T to Y draws that angle. And then it says R is somewhere in the interior. And I'm going to go ahead and draw ray TR because I know I'm going to need it. The measure of YTR is 41. The measure of angle RTW is 19. We want to find the measure of angle WTY. WTY is the whole angle. So what do I need to do with these two pieces? Add them. 19 plus 41 is 60. All right, everyone do the next one on your own, please. So hopefully you got 134 degrees, yes? All right, the next one is slightly different. Do you want to try it first before I do it?
Yeah.
It's not crazy hard.
Is it subtraction?
Yeah, you've already done it, overachiever. If you're done, check your neighbor. Don't let your neighbor be wrong.
No, what is 40 minus 2?
40 minus 2.
Yes. Oh, that's totally like that. Come on. What'd you get?
How about you, Jake? I'm taking a wild guess, pick 38.
Mr. Davis,
Put
what'd you get?
49.
Oh my goodness, it's 38.
I got 38 degrees.
No, it's because I.
Then we're all on the same level.
Did you draw it wrong accidentally?
No, I put 49 instead of 47.
Oh. So what happened to Lauren brings up a good point.
And she's wrong.
On the quiz or on a test, gentlemen, there we go. On a quiz or on a test, if you copy something down wrong from the original, usually I will only take off a point unless it makes the problem way easier. Occasionally I have people who do what I call wishful thinking. They're like, I wish this was this number, and so they just make it that number. But if you just miscopy something, I usually just take off a point, and then what I do is I figure out what the answer would have been so that I can, follow along with what you've done. Okay? It's called a copy error. And it's not a huge deal. All right, let's do one with an angle bisector. If ray SA bisects angle WSD, so let's draw that. That's slightly different. What does it mean when it bisects the angle?
It cuts
What-
it in half.
Yeah, it cuts it in half evenly, right?
Yeah.
Did we learn this previously?
We did.
I have a question.
I have an answer.
Okay, so
The Nile River.
Oh. So you know how like if you
Mickey
have a-
Mantle? Ecuador. I'm trying to guess the answer without you saying the question.
Okay, so you know how if you would have like a rectangle, right, and then you make, or not a rectangle, a square, and you like mark the little lines on there to say like it's like exactly the
Yeah,
same.
yeah.
Could you put that instead of like the little half or quarter circle thingy instead of,
What things are you referring to? You said you
know
mark.
what? Never mind.
Well, no, I just wasn't following. What things are you marking?
Like if you were to put for the bisect and you had to like make it like even, you had to do like little that.
Right.
thingy.
So this is how we mark that these two are the same.
Yeah. So instead of like doing those,
Yes.
could you make like a little like line like in between,
A little line.
like how you would do for like a square?
Hey, gentlemen, let's not talk. And I know that you may not be interested in this conversation, but no
Okay.
is the short answer.
Okay.
And notice that I put these different distances from the vertex so it doesn't look like it's just one arc. So it says then that angle DSA, that's this angle, is 58 degrees. Remember when it says DSA, that means D is on one side, A is on the other, and S is the vertex. So how much is WSA? 58 also. It says right here that these two are congruent to each other. So then, Terrence, how are we going to find WSD, the whole big angle?
Excuse me.
Wow. Go ahead. Yeah, we're just going to add those together.
Mr. Davis,
Sir.
where does it say that they're congruent?
It cuts it in half between
Okay.
that.
Yeah, when it bisects it, it's just like a midpoint cuts a segment into two exactly congruent halves. An angle bisector cuts an angle into two exactly congruent halves. All right,
Student athlete.
couple more. This time it says angle CVB is a right angle. Well, I finally know how big to make this one. All the other ones I've been kind of guessing. So this is a right angle.
I love this one.
I'm glad you approve. And Y is in its interior. Well, that pretty much tells me I'm going to have ray VY. And it says the measure of angles CVY. C is on one side, Y is on the other. Here's the vertex. Is 37 degrees. Find the measure of angle BVY. This angle. B is on one side, Y is on the other side, V is the vertex. So, Lauren, since you love this one so much, tell me how you would find the measure of this angle.
90 minus 37.
Yeah, the whole angle is 90 minus 37 is 53. right, 2 more examples and we'll be done. 36, oh yeah, we've got plenty of time to do these. So for this one, it says Z is in the interior of angle GHJ. All right, so I'm going to draw an angle GHJ. And Z is somewhere in the interior, so I'm going to go ahead and draw ray HZ. Tells me the measure of angle JHZ. Where is angle JHZ, Matt?
It is between Z and J.
Yeah, it's this angle between Z and J. So this is 3x plus 12. And then it says GHJ is 7x plus 24.
Oh, that's subtraction then.
So no, don't get ahead of yourself here. So where is that?
Is that like the outside?
Yeah, it's the whole big angle. So I would mark it like this. This angle is 7x plus 24.
So it would be.
Whoa. We haven't finished writing stuff on the diagram. I'll let you tell me in just a moment. Okay. And then Jacob, where is angle GHZ? Yeah, it's in between G and Z. It's this angle. So this is 8x minus 16. All right.
So we would do 3x plus 12 plus 8x minus 16 equals 7x plus 24.
That is absolutely perfect.
I was going to say that, Mr. Davis. That was
I'm sure you were. So now we'll group like terms. So 11x minus 4 is equal to 7x plus 24. Subtract 7x from both sides. So that's 4x minus 4 is 24. Add 4 to both sides. I get 4x is 28. Divide by 4. X is 7.
Yay.
I got the answer.
All right, one last problem. In this diagram, we're trying to find the measure of angle TLM. So T is on one side, M is on the other side. That's this angle right here. But all they give me is the measure of angle DLM.
Well, an obtuse angle is 180.
An obtuse angle is 180? What?
It's a line.
I don't think that's what you mean.
Never mind, Mr. Davis.
What?
Obtuse is higher than 90.
But less than 180.
Less than 180.
Period.
What is 180?
Oh,
We don't call it, in this case, we don't call it a line. It looks like a line, but we don't call it that. What do we call it?
What's the name for it?
got it.
You got it, Tyler. That's roughly good.
I know.
Wait.
No, you got it, Tyler.
Okay, let me ask you another question. What is the primary characteristic of a line?
It's straight. A straight.
A straight what?
Line.
A straight angle.
Straight angle.
Oh.
A straight angle. The straight angle from D all the way around here to T is 180 degrees.
So I basically got it right.
So I just take 180 minus 137,
That's great.
and that's 43.
Yay. You like my phone?
All right, questions about that?